This is my little IR sensor test setup. I've got two photodiodes, transmitter, 5-volt power supply for the photodiodes that are set up as voltage dividers, both with 10K resistors. Here's a power supply supplying 90 milliamps to the transmitter. Got an oscilloscope probe here, an oscilloscope probe here, so I can see the voltage across each photodiode. Each photodiode is reverse biased. I believe it's reverse biased, where the negative side of the diode, the cathode, is to the positive rail, which goes to the positive of the power supply, and the anode, positive side of the diode, goes to the negative rail via the 10K resistor, which goes to the negative of the power supply. Looking at the oscilloscope, you can see the waveforms or the voltages across each photodiode with nothing above them. They're about 1 volt, a little bit less than 1 volt, and they're both not exactly the same. 2 volts per division. If I move my finger above the diodes from one side to the other, you can see the change. If I hold my finger directly on top of them, they max out at about 5 volts. Both of these photodiodes are reverse biased. I switched one of the photodiodes around so that it's forward biased. The positive side of the diode, the anode, is to the positive rail, and the negative side, the cathode, is to the negative rail via the 10K resistor. Looking at the oscilloscope, you can see that the forward bias photodiode is 0 volts, where the reverse bias diode that I left alone is where it was before. If I move my finger across the top the photodiodes, you can see that the reverse bias one changes as usual. The forward biased only moves a little bit. If I change the voltage per division for the forward bias diode and I move my finger across it, you can see that it moves a little bit, but that's about it.